recall that to solve an ODE means to find all its solutions, right? So the verb to solve means that you have to find all solutions, and there are infinitely many. So let me emphasize it, that there are infinitely many. There are always infinitely many solutions of a differential equation. But very often, you don't need to know infinitely many solutions, so instead you need to find a particular solution, right? So for example, if you have a cat that fell out of the window, what you know that since it fell, right, so its initial speed is 0. And then if you know that its motion is governed by a differential equation, and you know that its initial speed is 0, so the question is to write down the equation for the cat's speed, for instance, to figure out if it's going to die in the fall or not. So what's going to be its terminal speed? Or so suppose that the population of, say, I don't know, a city like Singapore grows according to a certain law, right? So here I use the same equation as I set up for bacteria, but it probably makes sense for Singapore too. Like, so here the equation tells us that the initial population is 3 million, and the limiting population, theoretical limit when t goes to infinity, is 7 million. So the question is to predict the population in 2050, so for the modeling purposes, for example. That is an important question. I mean, although we know theoretically that the population approaches 7 million, but at 2050, what is it going to be like? Is it going to be 6 million, 5 million, 3.5 million, so what? Right, so an initial value problem for a first order differential equation consists of the differential equation and the initial condition. So here is a particular example of the initial value problem. And again, we can easily verify that this indeed is a solution of the initial value problem by just checking that it satisfies the differential equation first and the initial condition, right? So let me maybe emphasize it. So it must satisfy the original ODE, so the differential equation, and it must satisfy the initial condition. And then again, if you have a specific formula, then it is very easy to verify that it is indeed a solution of the initial value problem, so you just need to substitute it to the differential equation and to the initial condition. Of course, a much harder question is to solve an initial value problem. Alright, let me maybe highlight once again that there is usually just one solution. So later in a few weeks we will learn this general theorem that tells us that under certain mild restrictions the initial value problem always has a unique solution, so that there is one and it is precisely one solution. But for the time being it's just good to know that a differential equation has infinitely many solutions, but its initial value problem always has just one solution.